So for this section, we are going to be solving absolute value inequalities. So before we get started, I wanted to kind of do a little bit of a reminding of what we've talked about thus far, both about absolute values and inequalities. So first of all, from our last section, if you'll remember, we talked about the fact that the absolute value is the distance a number is from zero. And then from the previous section, we also talked about inequalities, and these are equations that involve a less than or greater than, or less than or equal to or greater than or equal to. If you'll recall, when we write or graph these, the less than or equal to or greater than or equal to use a closed bracket. That's our squared off bracket here. A less than or greater than, those use an open parentheses, so that's our parentheses. And anytime we go to infinity, whether that be positive or negative, we always use that open parentheses because we never can actually reach infinity. So what I wanted to do to start off with is just go over a couple of examples with some numbers and talk about how to graph them and how to write them in interval notation, because that can be a little bit confusing when we're dealing with absolute value inequalities. So I wanted to start off for example, looking at the absolute value of x is less than 5. And we're going to start this off by actually doing a number line. So what I want you to think of is, here's my number line, and here's 0. I've got 1, 2, 3, 4, 5, and then -1, -2, -3, -4, -5. Sorry, I didn't make my line quite long enough on the other side. Now, when we think about, and I just want to think about the positive side of this for a second because it's much easier to think of the positive side. When I think about x being less than 5, those numbers are 4, 3, 2, 1, and 0. All of those numbers are less than 5. So I know that my graph is going to definitely be this area between 0 and 5. Now this is where it starts to get a little tricky and you have to think a little bit, because remember that absolute value is the distance a number is from 0, but also makes everybody positive. So if you start thinking about the negative side of the problem, obviously if I do the absolute value of -1, let's say, that is going to be less than 5. And I can go all the way up to -5 and say, yes, if I do the absolute value of 5, it'll be less than what I'm looking for. But when I go to the absolute value of -6, so the absolute value of -6 is 6, and 6 is not less than 5. So I can't go past -5, because anything past -5, when I take the absolute value of it, it becomes positive, and therefore it's bigger than 5. So it would be all of these numbers on the negative side from -5 up to 0. So notice that we've kind of bound our interval. We're saying it has to be bigger than -5, but it has to be smaller than +5. Now the other thing we have to talk about when we're doing this is, what symbols do we use? And this is very similar to what we talked about when we were solving inequalities. Because I'm sitting here with this less than symbol, remember that is an open parentheses. We were just talking about that a second ago. That means at both sides of this, I am going to have an open parentheses on my graph, because I can't actually be the number 5 because 5 isn't less than 5. But I can go right up close to it. So that means we want to be able to write both our interval notation, and I really like writing my interval notation directly from the graph. I find it's the easiest way to do that, because it's basically, interval notation is a representation of whatever you've just graphed above that. So for our interval notation, our graph started at -5 with an open parenthesis, so we'll have -5, and it ended at 5, +5, again with a parentheses. So definitely interval notation is the easiest thing read off of directly from your graph. Now we also want to talk about the algebraic notation, and for this particular graph it's going to be a little harder than our interval notation, but not impossible. Remember, what we're doing here for our graph is we're telling you that whatever value we pick, whatever x is, it has to be greater than -5, but less than positive 5. And so the way that we do that is we do that compound inequality. So we say, well, we have negative 5, and x has to be bigger than that, but x cannot be bigger than a positive 5. So we use that algebraic notation, or that what we call a compound inequality. Okay, well, now let's look at what happens and what's the difference if we say that x has to be less than or equal to 2. Okay, again, the same idea here. Here's my number line. I've got, here's 0, 1, 2, 3, and on the other side I've got -1, -2, -3. I'm still saying that x has to, or my absolute value has to be less than 2. So if I'm thinking just on my positive side, that would mean that I have the number 1. 1 is less than or equal to 2. So all of this area between 0 and positive 2 is less than 2. Well, on the opposite side with my negatives, because remember I'm working with an absolute value, all of those numbers are going to be turned positive when I put them in the absolute value. So the numbers that would work for me here, again, are going to be from -2 up to 0. Because if I tried to use the number -3 and I took the absolute value of it, the absolute value of 3 is 3, and that's not less than 2, so it doesn't work. So we get all of these numbers between -2 and positive 2. Now, again, we want to look at our inequality right here, and because he is less than or equal to, this is going to be a closed bracket on either side of our -2 and our positive 2. So really the only difference between a less than and a less than or equal to as far as your graph is concerned is the endings. So on the less than we had parentheses, we're here on the greater than we have, or greater than, or excuse me, less than or equal to, we have the brackets. But our interval notation, again, is just a representation of our graph. So this is going to start at -2 with a closed bracket and go to +2 also with a closed bracket. And then for our algebraic, we're going to have from -2. Now this time, because we're having a bracket, that's less than or equal to. I'm allowing 2 to be part of my answer, so I'm actually going to use a less than or equal to x, and then less than or equal to 2. Now, let's see what happens when we look the other direction. So instead of doing a less than, let's do a greater than. So again, we're just looking at our examples here. So we have the absolute value of x is greater than 1. Okay, and again, I'm going to do this by looking at my number line. So I have 0, 1, 2, 3, and then -1, -2, -3. And I'm wanting this time, I'm wanting the absolute value of my x to actually be bigger than 1. So if I'm, again, thinking on my positive side, what values are bigger than 1? Well, that would be 2, 3, 4, 5, 2 million. Okay, so everything from +1 out to the right-hand side all the way to infinity would be considered being bigger than 1. Conversely, if again I'm making every negative number a positive when I take the absolute value, then everything to the left of -1 would also be considered bigger than 1 when we take the absolute value of it. So when we do greater than, notice that instead of shading in between -1 and +1, we're actually shading to the outsides of -1 and +1. And so our interval notation is going to look a little weird because we do have two distinct intervals as part of our graph. Oh, and before I write the interval notation, let's talk about what we're going to use here at -1 and +1. Again, we're saying greater than. Remember, greater than does not allow an equality, so we are going to use a parentheses here at -1, and we're going to use a parentheses here at +1. So now let's do our interval notation. And again, this is going to be the kind that's just a little bit weird because we do have two distinct pieces of our graph, so we're going to do them separately actually. So the interval notation for this portion, or the negative side of our graph, is going to be open parentheses. We're going to do negative infinity up to -1, and again a parentheses because we're not allowing equality at -1. Remember, we're doing a parentheses at infinity because we can never actually get there. Now, to connect this portion of our interval with the second one, we're going to use what we call a union, which is just this U-shaped thing. This is not the letter U, it's a U-shaped mathematical symbol. And then we're going to start our second interval, or this positive side of our interval, and it's going to go from 1 all the way out to infinity. And we're going to do another parentheses again because we can't ever reach infinity. Now on the plus side, our algebraic notation is a little bit easier to do on this guy. So when we're doing our algebraic notation, it's very similar. We have to have two different notations for our algebraic notation because we do have two separate intervals. So that is going to be that x needs to be less than -1, or x needs to be greater than +1. Alright, one more thing we want to look at before we start doing some examples is what happens when x is greater than or equal to, let's say, 4. Again, thinking about our number line, here's the number 0. I'm going to cheat a little bit on this guy, and let's just label from -4 out. Again, we're wanting x, or the absolute value of x, to be greater than the number 4. Well, the things that are greater than 4 are 5, 6, 7, 8. So that means that if we're thinking about our positive side again, we're starting at 4 and we're going out to infinity. We're going to go that way forever. Again, thinking on the negative side, because remember, when we take the absolute value of all these negative numbers, they're going to become positive. So everything from -4 out to -infinity would also work for our equation. Now again, looking at our symbol here, we're doing greater than or equal to, so the or equal to is a closed bracket, so at -4 we'll have a closed bracket, and at +4 we'll have a closed bracket. So this is for our interval notation. We're going to have from -infinity up to -4 with a closed bracket. We're going to union that with 4 out to infinity with an open parentheses and a closed bracket at 4. Notice, remember, these guys don't have to match. You make these decisions based on the numbers that are present. And then for our algebraic notation, we're going to have x is less than or equal to -4, or x is greater than or equal to +4. Okay, so let's try some actual